All right, so today I'm going to be going over solving equations using the zero product rule. This is basically the method that you use when you solve by factoring, and so we're going to be doing a lot of factoring because this video is meant to teach you how to solve by factoring, not to teach you to factor. I'm not going to spend a lot of details on the factoring portion of it. So if you do need to review factoring, you can go back and watch my factoring videos, or you can pause when you're watching this and then complete the factoring yourself, because I'm going to be mostly doing the factoring in my head unless it's a longer one. So there may be some details that you need to write down that I am not writing down. So you can fill those in on your own in your own notes and then resume to continue the video while you're watching it. So we're going to start with the definition of a quadratic equation. So a quadratic equation is an equation where the highest exponent on a variable is 2. And so because of that, this is also called a second degree polynomial. So we've talked about trinomials, and most of our trinomials had the highest exponent being 2. So that is called a quadratic when it's put into an equation. Generally, we always have our quadratic equation where it's set equal to 0. So it's ax squared plus bx plus c equals 0. In order to solve these, you always need to have them equal to 0. So that's the standard form, but basically you put everything on one side and then you solve. Now the zero product rule, it's based off of very basic arithmetic. So we know that anything multiplied by 0 is 0. Like 5 times 0 is 0. So if you have two numbers that are multiplied together and you get 0 out, then one of them, or maybe both of them, but at least one of them has to be 0, because that's the only way you can get something to multiply and be 0. So that's the idea behind the zero product rule. If a times b is equal to 0, then a equals 0 or b equals 0. And it's possible they're both 0, but those are your choices. And so that's the zero product rule, and that's what we're going to use. When we factor, we turn things into multiplication, and then once we have things multiplying to 0, that's when we can use this rule. So these two are already factored for us so that I can just demonstrate how the zero product rule works. So on the first one here, I have x minus 5 times x plus 1 equals 0. So when you have it factored and you have something times something equals 0, then to use the zero product rule, we set each factor equal to 0. So I have, oops, I'm in the highlighter still. Let me actually go back to the pen. So we have x minus 5 equals 0 and x plus 1 equals 0, because at least one of those needs to be 0. And then you solve both of those for x, and that will get you your value. So if I add 5 to both sides, I get x is equal to 5, which is one solution. And then if I subtract 1 from both sides, I get x is equal to negative 1, which is our second solution. Quadratic equations have two solutions. That's because the highest exponent on them is a 2. So that exponent tells you how many solutions you should have. So we have two solutions here. Our second one, we have 3x minus 2 times 4x plus 7 equals 0. So again, this is already factored. So I set each factor equal to 0, and then I solve. So the first one, I need to add 2 to both sides. And this gives me 3x equals 2. Then I divide both sides by 3, and I get x equals 2/3. So that's one solution. The second one, I subtract 7 from both sides, which gives me 4x equals negative 7. And then I divide both sides by 4. I get x equals negative 7/4, and that is your second solution. So once it's factored, the solving is actually quite easy. So because you're just solving a linear equation after that. So the hardest part is probably the factoring part. Here are a couple more. So I have 2 times x minus 7 times x minus 7 equals 0. So the 2, we can ignore that because it doesn't have a variable. If we set that equal to 0, that would be 2 equals 0. It doesn't mean anything. So we only need to set x minus 7 equal to 0. But since it shows up twice, we only really need to have it once because we're going to get the same answer twice. So we have x minus 7 equals 0. We add 7 to both sides, and you get x equals 7. Now, this came out, we have one number that's a solution. Excuse me. But it is still a quadratic because the x minus 7 was written twice. We consider this a double root. Root is a term that you will learn when you get to college algebra. The double just means that it shows up twice. So we still have two solutions. It's just the same solution twice. The next one, we have x times 3x plus 8 equals 0. So I have x equals 0, which is really easy because I've already solved that one. And then 3x plus 8 equals 0. So I need to subtract 8 from both sides. And this gives me 3x equals negative 8. And then I divide both sides by 3. I get x equals negative 8 thirds. And there's my solution. So those are two more interesting examples that are not always straightforward like the first two. So I wanted to pick some that were a little more interesting. So now let's actually get into solving by factoring. So to solve a quadratic equation by factoring, first you have to put it in the form where it's equal to 0. Then you factor, and then you apply the zero product rule. And you can always check your answers in the original problem, which is the best place to check it, just in case you factored wrong. So let's get going on these. So this first one, because there's no coefficient in front of the y squared, this one is easy to factor by trial and error. I know that I'm just going to have a y times a y. And you need to remember to put that equals 0 there because it's still an equation. We're just factoring that left side. So we have two numbers that multiply to negative 8 and add to negative 7. And that will be negative 8 and positive 1. So now I have this factored. So now I set each factor equal to 0. So I have y minus 8 equals 0. Y plus 1 equals 0. And then I solve each of these. So I add 8 to both sides for the first equation, which gives me y equals 8. And then I subtract 1 from both sides, which gives me y equals negative 1, and that's my second solution. So the factoring is just the hardest part, and if you're really good at factoring, then it's really not so bad. The second example here, we have 4x squared minus 11x equals 8. I mean, equals 3. I don't know why I said 8. We have to get it equal to 0 first. So I have to subtract that 3 from both sides so that I have one side equal to 0. So I have 4x squared minus 11x minus 3 equals 0. Now I can factor. This one I'm also going to factor by trial and error just because they're relatively small numbers. There's only one possible way to multiply to 3, so I know it's 1 and 3. I just don't know whether it's a positive or minus in each spot. And so I can just do some quick guessing and checking. If I need to get to a negative 11, I'm guessing that I could do 4 and 1. If I have 4 times, and I need to put my x's in there. So if I do a 4 times a negative 3, that's me negative 12. And then plus 1x, that gives me 0. I mean, negative 11. Oh, my brain. So I've got 12x minus 1x. I mean, negative 12x plus 1x, that gives me negative 11x. So now that I've factored, I set each factor equal to 0. So I have 4x plus 1 equal to 0, x minus 3 equal to 0. So for the first equation, I subtract 1 from both sides, and I get 4x equals negative 1. Divide both sides by 4. X equals negative 1/4. Second equation, I just have to add 3 to both sides, and I get x equals 3. And there I go. Okay, here are a couple more examples. I'm going to, get a little more complicated as I do. So first one, 4a squared minus 49 equals 0. So this is one of our special factors. This is the difference of squares, because this is 2a squared minus 7 squared equals 0. So this factors to 2a plus 7 times 2a minus 7, and then we have equals 0. So then I set each one equal to 0. So I have 2a plus 7 equal to 0, 2a minus 7 equal to 0. So for the first equation, I subtract 7 from both sides. I get 2a equals negative 7. Then I divide both sides by 2. I get a equals negative 7 halves. Second equation is essentially almost the exact same steps. I add 7 to both sides, which gives me 2a equals 7. Divide both sides by 2. A is equal to 7 halves. Now, this second equation I have here, 0 equals 2t squared plus 20t plus 50. It's always easier to take the greatest common factor out first and then factor, because it will make things easier for you. You'll be dealing with smaller numbers. So I can factor a 2 out of everything. So I have 0 equals 2, and then in parentheses, t squared plus 10t plus 25. Now I need to factor t squared plus 10t plus 25. And this is actually a perfect square trinomial. So this factors to 10t plus 5 squared. So it would be t plus 5 times t plus 5. So it's one where this t plus 5 shows up twice. But because it's the same, we only get one factor out of this when we start solving. So I only have to set the t plus 5 equals to 0. So then when I solve, I get t equals negative 5. That 2 in the front doesn't matter because it doesn't have a variable. Okay, now moving on, we have 3n cubed plus 4n squared plus n equals 0. So this is not quadratic, but I can factor an n out. So I'm going to factor n, and this gives me 3n squared plus 4n plus 1 equals 0. So I need to factor the 3n squared plus 4n plus 1, and this one's easy enough to do by trial and error because there's not a lot of choices. And if I have to get it to 4n, this will be 3n plus 1 times n plus 1. So now I have 3 things that are set equal to 0, and that first one's not a number, it actually has a variable. And the zero product rule applies even if you have 3 things multiplied together. So I have n equal to 0, which is one solution. Then 3n plus 1 equals 0. And then n plus 1 equals 0. So because my highest exponent was 3 in the original problem, I'm going to end up with 3 solutions. So for the 3n plus 1 equals 0, I need to subtract 1 from both sides. This gives me 3n equals negative 1. Then I divide both sides by 3, and I get n equals negative 1/3. Then with n plus 1 equals 0, I subtract negative 1, or subtract 1. And this gives me n equals negative 1 as my third solution. Next, I have 9n squared equals 1, so I have to make it equal to 0, so I have to subtract the 1 from both sides. And generally, we want the highest term to be positive, so that's why I subtracted the 1 and not the 9n squared. So I have 9n squared minus 1 equals 0. This is another difference of squares. This factors to 3n plus 1 and 3n minus 1. So that's equal to 0. So then I have 3n plus 1 equals 0, 3n minus 1 equal to 0, and then I solve each of these. So for the first one, I'm going to subtract 1 from both sides. This gives me 3n equals negative 1. Divide by 3. You're going to get really good at solving here. N is equal to negative 1/3. The second one, I add 1 to both sides. I get 3n equals 1. Divide by 3. N is equal to positive 1/3. And now these are the last two that I have for you. These are a little more complicated. So these look like they're factored already, except they're not equal to 0. So we can't use the zero factor property at this point because it's not equal to 0. So we have to actually multiply it out, put everything on one side, factor, and then use the zero product factory property. So I need to multiply my 3q times the q minus 3. So that gives me 3q squared minus 9q equals 12. Then I need to get everything on one side. So I subtract the 12 to get 3q squared minus 9q minus 12 equals 0. Now I notice that I can factor 3 out of here, so that's going to make my life easier. So that's 3, and then in parentheses, q squared minus 3q minus 4 equals 0. So then I'm going to factor. So I have 3, parentheses, and this factors to q minus 4 times q plus 1 equal to 0. So that gets me a negative 4q plus 1q, that's minus 3q. Then I set each of these equal to 0. So I don't have to set the 3 equal to 0. So I have q minus 4 equals 0, q plus 1 equal to 0. And then when I solve, I get q is equal to 4, and q is equal to negative 1. So there were a couple extra steps because it's not set equal to 0. Same thing on this example on the right. So I have w plus 5 times w minus 3 equals 20, but it's not equal to 0, so I have to multiply, put everything on one side, then factor, then zero factor property. So when I multiply, I'm going to FOIL that out. This is going to give me w squared plus 2w minus 15 equals 20, because 5w minus 3w is a positive 2w. Now I'm going to subtract 20 from both sides, and this gives me w squared plus 2w minus 35 equals 0. Now I'm going to factor. This factors to, let's see, w plus 7 times w minus 5 equals 0. So 7w minus 5w gets me my 2w. Then I set each factor equal to 0. So I have w plus 7 equals 0, w minus 5 equal to 0. I subtract 7 from the first equation and get w equals negative 7. And then I add 5 in the second equation, and I get w equals 5. And that's it. That is the method for solving by factoring. And basically, the biggest step is just making sure you factor, and then from there, it's pretty simple. So if you have any questions, you can send me an email or give me a call. And if you're struggling with factoring, you can go back and review those factoring videos that I have. Thank you for watching. I hope you guys have a great night.